Hello everyone, welcome to my class. In today's class I am going to cover the law of cosine and the area of a triangle. So let me start the class right away. First, quick recall. As an application of trigonometry, we study two laws, the law of sines and the law of cosines. These laws can be used to solve oblique triangles. Oblique triangles are non-right triangles where we cannot apply the trigonometric functions to solve such triangles. In our last class, we covered the law of sines. Law of sines is used to solve an oblique triangles when we know the three parts such as angle, side, angle, 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 side, and side, side, angle. To find the other missing sides and angles, we use the sine laws. Now, in today's class, we are covering the law of cosine. Law of cosines can be used to solve an oblique triangle if we know side, angle, side, and side, side, side of a triangle. Next, quick recall the law of sines for any triangle ABC. Here is a triangle ABC. Here is a triangle ABC. The side opposite to angle A is denoted by lowercase a. The side opposite to angle B is denoted by lowercase b. And the side opposite to the angle C is denoted by lowercase c. Then in sine laws, we have these ratios are equal. Sine A over side A equals to sine B over side B equals to sine C over side C, or equivalently side A over sine A equals to side B over sine B equals to side C over sine C. Awesome. Now let's move on. So next, the law of cosines. For any triangle ABC and corresponding sides little a, little b, and little c, the diagrams here, the following relations are true. A square equals to b square plus c square minus 2bc cosine a. Similarly, b square equals to a square plus c square minus 2ac times cosine b. Similarly, c square equals to a square plus b square minus 2ab cosine c. Or equivalently, from the first relations, let's take a square to the right side and take negative bc cosine a to the left side and divide both sides by 2bc. Then we got cosine a equals to b square plus c square minus a square over 2 times bc. Similarly, from second relations, rearrange the term. This gives us cosine b equals to a square plus c square minus b square over 2 times ac. Similarly, from third relations, by rearranging the term, we will get cosine c equals to a square plus b square minus c square over 2 times ab. Awesome. So, these are the cosine laws. So now, quick side note. Side note number 1, if that's better. If the included angle is 90 degrees, the law of cosine reduces to the Pythagorean's theorem as cosine 90 degrees is 0. The law of cosine is used to solve the oblique triangles when you know this three parts, SAS and SSS. Means SAS means side, angle, side. Angle is included between two sides. And we know the three sides, then we use the cosine rule to solve the triangle. By the way, the solving the triangle means finding the missing sides or missing angles of the triangle. There are three angles and three sides of a triangle. 3. There is no ambiguous case in this method, as inverse cosine returns an angle between 0 and 180 degree. 4. Some applications of the law of cosine involved finding navigations, surveying, and solving recreational exercises. So next, let's talk about finding the area of oblique triangles using the sine functions. Formula. It turns out that area equals to 1/2 AB times sine C, or area equals to 1/2 BC times sine A, or area equals to 1/2 times AC times sine B. Again, our triangle is an oblique triangle. It's not a right triangle, so we cannot use the area equals to half base times height for finding the area of a triangle. Or equivalently, the area formula turns out to be A equals to A squared times sine B sine C over 2 times sine A, or area equals to B squared times sine A sine C over 2 times sine B, or area equals to C squared times sine A sine B over 2 sine C. Awesome. Next, quick note. The first formula says the area of an oblique triangle, in this case here, is equal to 1/2 the product of two sides times the sine of their included angle. Here angle C is in between these two sides A and B. C is included angle. Great. Next, Heron's formula to find the area of oblique triangles. We have another alternative formula to find the area of oblique triangles. When all three sides of an oblique triangle are known, the area of triangle is then area equals to, under the radical, S times S minus A times S minus B times S minus C, where S is semi-perimeter, which is A plus B plus C over 2. Awesome. Next, remark. We often use the law of sines after using the law of cosines to complete a solution in solving triangles. Now, let's do some example. Example 1. Answer the questions part A and part B. In part A, solve the equations for the unknown part. So, given equation is 4 square equals to 5 square plus 6 square minus 2 times 5 times 6 times cosine B. Here the missing part is angle B. So let's find the value of B. Solutions. So here, 4 square is 16 equals to 5 square is 25, 6 square is 36, and 2 times 5 times 6 is 60 times cosine B. So to find the value of B, so let's isolate the term cosine B alone to the left hand side and multiply by the cosine inverse. That's the idea. So the next step, so bring negative 60 cosine B to the left side, so it becomes positive 60 cosine B. Then here, take 16 to the right side, it becomes a negative 16, so we have 25 plus 36 minus 16, which turns out to be 45. Next, divide both sides by 60, then cosine B equals to 45 over 60, which is approximately, using calculator, 0.75. Then apply both sides the cosine inverse, then we will have B equals to cosine inverse, which is approximately 0.75. Using calculator, it turns out that B equals to approximately 41.41 degree. I hope this algebra makes sense to you all. So now let's do part B. Solve the triangle with sides. Side A is given to us, angle B is given to us, and side C is given to us. So now let's find side B and two other angles, angle A and angle C. Solutions: need to find side B and other two angles, angles A and angle C. Use the cosine rule followed by the sine rule. First, by the law of cosines, so b square equals to a square plus c square minus 2ac cosine b. Let me show you the formula here. I applied this formula here because we are finding the side b, so I use this middle formula. Let me scroll down again. So here, so b square equals to a square plus c square minus 2ac cosine b. Then let's plug the values here. The next step, b square as it is, a is 12.9 square and c is 25.8 square, minus 2 times a is 12.9, c is 25.8, angle b is 30 degrees, so cosine 30 degree. So in the next step, let's use calculator here. 12.9 square turned out to be 166.41. 25.8 square turned out to be 665.64. And this minus as it is. Now 2 times 12.9 times 25.8 turned out to be this number, 665.64. And cosine 30 degrees simply radical 3/2. Now simplify this number, gives you approximately 255.59, and take both sides the square root, then b turns out to be approximately 16 meter. Awesome. So next, to find the angles A and angle C, let's apply the law of sine. So from law of sine, we know sine angle A over little a equals to sine angle B over little b. So we know A is given to us, angle A is we need to find out, angle B is given to us, side B we just found here. So then let's plug the values here. So sine A over 12.9 equals to sine 30 degree over 16. Cross multiply. Then it turned out that sine A is approximately 0.4. Then applying both sides by sine inverse, then we got A equals to sine inverse 0.4, which approximately 23.58 degree. Hence we found the angle A. Now we already know the angle B, then we can easily find the angle C by using this relation. So angle C equals to 180 degree minus 30 degree plus 23.58 degree. After simplifying, we will get angle C equals to 126.4 degree. I hope it makes sense to you all. By the way, this 180 degree is the sum of all angles of a triangle. Awesome. Now let's move on. Let's do example 2. This time let's find the area of a triangle. So here side A is given to us, side B is given to us, and angle C is given to us. We know the area formula. Here the angle is included between these two sides, so we apply this formula. Area equals to half AB times the sine C. This equals to 1/2 times A is 110, B is 225, angle C is 30 degrees, so sine 30 degree. In the next step, we know sine 30 degree is 1/2. After simplifying, we got area equals to 6,187.5 square centimeter. Awesome. Next, let's find the area using Heron's formula. So the example 3, that's better. A NYCT developer wants to build condominiums on the triangular lot. So you have a triangular lot. how many square meters does the developer have to work with if the frontage along each street is approximately 34.1 meter, 43.5 meter and 62.4 meter respectively. So the triangular lot sides are approximately given here. Solutions. To apply the Heron's formula, we have to find out the semi-perimeter. That means we need to find out the S equals to A plus B plus C over 2. So first, A plus B plus C means 34.1 plus 43.5 plus 62.4. This sum turns out to be 140. Then divide by 2. Then semi-perimeter S equals to 70. Then we have the formula here. Let me show you the formula again here. That's the formula. S is semi-perimeter and the area formula is here, which is under the radical, this term here. So let me scroll down. So here, then area equals to, under the radical, S times S minus A times S minus B times S minus C. S is 70, A is 34.1, B is 43.5, C is 62.4. Then subtract, multiply, take the radical. It turns out that the area is approximately 711.42 square meter. I hope this computation makes sense to you all. Now let's move on. Example 4. The applications problem, trip planning. So here, a troop of scouts is planning a hike from Montgomery to Pattonville. So here is a Montgomery, here is a Pattonville. They calculate the distance using a map using Bradleyton for reference, since it is due east of Montgomery. So here is a Montgomery, here is a Bradleyton, and here is a Pattonville. So the question is, what is the measure of angle M? So here, by the way, the distance from Montgomery to Bradleyton is 21 mile, and Montgomery to Pattonville is 18 mile, and the distance between Pattonville and Bradleyton is 10 mile. So the questions here, we need to find out the angle M. So here the three sides are given. So obviously we are using cosine law to find the missing angles. B, what heading should they set for this trip? So let's begin the solutions. First part A, by the law of cosines. So here, cosine M equals to P square plus B square minus M square over 2 times P times B. That's a formula. So here, P is given, B is given, M is given. So plug the values and simplify. It turns out that cosine M is approximately 0.88. Then apply the cosine inverse both sides. Then we will get M equals to cosine inverse 0.88, which is approximately 28.36 degree. Awesome. Now part B. So consequently, the heading is 28.36 degree south of east. So here is a south of east, that is heading of 90 degree plus 28.36 degree, which is 118.36 degree. By the way, the headings are understood to be the amount of rotations from due north in the clockwise directions. So going here is going there and going there. So I hope it makes sense to you all. Now we finish section 7.2, the cosine law and the area of an oblique triangle. So thank you.